good, and we can provide methods for getting that access token. But how do we get that to the client without actually giving it away? Obviously, there's a lot of power to who possesses this single access token. Like if anyone else gets it, then they are that person on that site, and then they can, do whatever that site has permission to do on behalf of the user. So we really need to make sure that this isn't leaked at all, if at all possible. So this is the flow. Essentially, if you try to, you start a login attempt from your client site, we open up a pop-up window at this stage, or you can just redirect in the same window to an SSL endpoint on the service, so on twitter.com, and we ask them where they can actually log in and authorize this transaction. The URL that we use to do that looks something like this for us, but basically it has a type which says there are various ways of using OAuth 2, and the one we use is the user agent flow. So we specify that. We also give the client ID, which the client needs to sign up for an application. They get this ID. And then the third thing is the redirect URI, and that's normally just the page that they happen to be on at the time. But the interesting property of this is when the client signs up for an application, we actually ask them for one or more domains that their application is going to be on. So for instance, msnbc.com will say the MSNBC application works on msnbc.com, sports.msnbc.com, and so on. So they have a list of allowed domains. And then we can actually verify that the callback which is sent comes from one of those domains. If it's true, then that's correct, then we can redirect back to their site. Obviously, if you try to put another domain in and you're just sort of stealing another site's client ID, then this mechanism just fails. So this is the means by which we can know that we can be sure that the client is who they say they are. Then, the user logs into Twitter, so now we know that piece of information, and then after that they authorize that this client can do things on their behalf, so that's the third part of the puzzle. After this happens, we actually do the redirect within the pop-up window, and this is the HTTP request with all of the kind of extraneous stuff removed. The thing to note here is in the redirect, which is also sent over SSL, we have in the location we have the callback that was given, but also we put the OAuth access token actually in a hash after a hash. The interesting property of that, which is where the magic comes in, is the browser will receive this over SSL, so it's not going over the network in the clear at all. But then the browser has to act on that redirect and follow it, but it actually doesn't send the hash portion, because that's just to, where the fragment identifier. So it doesn't need to send it. It actually goes and uses this request to follow that redirect, and by that point the access token isn't sent, which is great because now we have redirected back to their client site, which doesn't necessarily have to be SSL, and we've given them the token in a way where it's never gone over the network in the clear. So the client site just totally doesn't need to support SSL to be able to sort of do this securely. The final part is pretty easy. So now we've got up here in this pop-up window, that is now a Twaudio URL, and which means that its parent window can talk to it again. So inside the pop-up window we'll have some code like this that says parse the token out of the hash. If we have access to the Windows opener and we can actually get to the set token method, then we'll actually call that method in the main window and give the token to the main window. And there we have it. Now we have securely, without anything going over the wire in the clear, got a token. There are like a few warnings with this. The first thing is it's secure. Like for our part, we've got this access token to the browser without it ever going over the network, and it can't be sniffed. The problem is it's quite easy to leak these things. For a start, like many sites might try and keep them in a cookie, and obviously cookies get sent with every HTTP request on that site, so they can then be sniffed. So people shouldn't definitely not do that. But you can store in local storage. That works. Yeah, and it's just so there's all kinds of ways they could send these things in XHR requests and do all kinds of things to leak these tokens. And it's quite difficult to totally prevent the developer of the client side doing things like that. So the best thing we can do is actually make the token last a very, very short amount of time. At the moment, ours lasts about an hour, but I think we'll probably chop it down to like maybe 10 or 15 minutes, and that very much limits the space of time that anyone who gets this token can do any damage in. If you are doing that, you can use an immediate mode, which I won't go into in this talk because it's a little bit complicated, but you can basically, if you know the user on twitter.com and they've already given permission, you can use this immediate mode to sort of silently get a new token when one runs out. So we've got the token. How do we use that to actually make privileged calls to the API? So we're looking at our remote call again, which we saw before. The only addition is that we now, as well as the method, the arguments, and the token, we now send the token. So, and then our new our public methods also take a token as an argument, and then with that token, they set a header on the XHR request. So, using like set request header, and in the OAuth specific format, and then plug in the access token. With that access token, our servers then can look up the user, look up the client, and verify that access token, and basically act as that logged in user. So that was the sort of end-to-end process. I sort of simplified some of the details just to get the main message across. So hopefully you'll know where to go and what to look for if you need to implement a similar thing. So yeah, we talked about cross-domain communication. We talked about layering the RPC layer on top of that. We talked about actually wrapping the REST API, and then finally how to add authentication and authorization to that. And yeah, that's me. So we've got sort of like 10 minutes or so for questions, if you have any.
Hey, I love the window name hack.
Oh, you shouldn't. It's awful.
Do you have the same problem with strings with the HTML5 post message function, or can you pass an object there instead?
Yeah, you can pass whatever you like through there. We actually don't. Just to simplify the cross-browser solution, we just JSON encode, send it over, and decode at the other end, just because you need to do that for all the other solutions, so we just may as well. But yeah, you can pass values across. Yeah.
It's interesting that you chose to use, sorry, I'll stop that. It's interesting that you chose to use window name instead of just creating sort of a cubby system on the server, right? So if I want to post information from an iframe back to a page, you can imagine actually just doing it through another server. Is there a reason you chose not to do that? I mean, for performance, obviously, but is there a reason you chose not to do it that way? Before going to window mapping.
Yeah, well, I mean, the thing with that is that then you'd kind of, because we don't know who the client is going to be, and that we can't really verify like who's using our proxy, and then you sort of have this very nastily open proxy for connections that we'd rather avoid. I mean, we haven't actually implemented the local connection stuff yet. I mean, what I was going to say when we do that, when I was talking about that, is definitely get the person that you don't like in your company to do it, because it's infuriating.